Well, hello, math blocks 2, 3, and 4. It's Friday, March 20th, and what we're going to do today is I've got 4 multi-step equations for you to do as an activator that all involve distributing the negative, and then we're going to do some comparing functions work, or actually comparing rates of change, and then you'll be done for the day. This is all review stuff we've done before, so it should be pretty easy for you. So the first thing I'm going to do is work out the equations for the activator, and then make sure you do your activator on a separate sheet of paper, take a picture of it or scan it, and then upload it to Google Classroom for me. When we get to the actual comparing rates of change assignment, you can answer those questions directly on the Google document, and then you can just save that Google Doc to Google Classroom like we normally do. So let's get ready to do some multi-step equations. All right, so all of these that we're doing today, everybody, involve in distributing the negative, which was something that we did last week and we hadn't done in a while, but I wanted to go through it again so you guys can get really good at this, because when you get into Math 1 next year, you need to know how to do this. So problem number 1 is 6x minus 4 times 2x minus 3 equals 28. All right, so let me go ahead and zoom that in a little bit for you. All right, so what we have to remember here is that this is not just 4 times 2x minus 3, it's actually negative 4 times 2x minus 3. So this negative is going to travel with the 4 when I distribute into my parentheses. Okay, so when I do that, I still have 6x. So negative 4 times a negative 2 is going to give me minus 8x, and then negative 4 times 3 is going to create a sign change, because a negative times a negative is a positive, so that's going to give me plus 12, and all of that equals 28. Okay, so then the next thing that I do is combine my like terms. So 6x minus 8x is going to be negative 2x, plus 12 equals 28. Then the opposite of addition is subtraction, as I'm trying to isolate my variable. So I subtract 12 from both sides. So that gives me a negative 2x equals 28 minus 12 is 16. I divide both sides by a negative 2 at this point. And then x is going to equal a negative 8. All right. So that's the first one. So if you did this on your own, you should have negative 8 as an answer. All right, so number 2 is negative 3x minus 5 times negative x plus 2 equals 2. All right, so I do the same thing, is I'm going to distribute this entire thing. So the negative 5 is going to distribute to everything inside parentheses. So that's going to give me a negative 3x. So negative 5 times a negative x is going to give me plus 5x. And there again, those negatives produce a sign change. So let me just make that in red, so it stands out to us that a sign change occurred there. And then negative 5 times that positive 2 gives me another sign change. So that's going to become a minus 10. And all of that equals to 2. Okay? So then I distributed. Now I combine my like terms. So negative 3 plus 5 is going to give me 2x minus 10 equals 2. Then my next step is going to be to add 10 to both sides, because I'm trying to isolate my variable, and the opposite of subtraction is addition. So that gives me 2x equals 12. Divide both sides by 2. And x is going to equal 6. All right, so that's number 2. Okay, so here's number 3. I have 4x minus 4 times a negative x minus 3 equals a negative 36. All right, so I've got to do the same thing here. When I distribute, I'm distributing a negative 4 to everything on the inside of those parentheses. So when I do that, that gives me 4x. So a negative times a negative produces a positive. Okay, so that's going to make a sign change there. So I'm going to have 4x plus 4x. Negative times a negative again is going to produce a positive. So 4 times 3 is going to give me 12. And all of that equals a negative 36. All right? So I distributed. Now I need to combine my like terms. So 4 plus 4 is going to be 8x plus 12 equals a negative 36. So now I subtract 12 from both sides. And I'm left with 8x equals a negative 48. So the last step is to divide both sides by 8. And I'm left with x equals a negative 6. All right, so my final one, number 4. Negative 7x minus 2 times a negative 3x minus 3 equals negative 1. So same thing is I'm going to distribute this negative 2 to everything that is in the parentheses. So I'm left with negative 7x. So when I do negative 2 times a negative 3x, negative times a negative makes a sign change, so that becomes a positive. Negative 2 times a negative 3 makes another sign change, so that becomes a positive. And all of this equals negative 1. All right, so I did my distributing, so now I just need to combine my like terms. So negative 7 plus 6 is going to be a negative x plus 6 equals a negative 1. Now I subtract 6 from both sides. And so I'm left with negative 6 or negative x equals negative 7. Because negative 1 minus 6 is going to be a negative 7. Now, we haven't talked too much about this, but the way I get rid of a negative variable, because I want my variable to be positive, is I'm going to multiply both sides by a negative 1. Because a negative times a negative creates a positive. And what I do to one side of the equation, I must do to the other side. So this is going to give me a positive x over here. And negative 1 times negative 7 gives me a positive 7. So x equals x equals 7. All right, so what I want you to do now is to open on your Chromebooks the assignment. It's called Comparing Rates of Change. I'm going to pause this video and then set up to do 2 examples for you of comparing rates of change. So give me a moment, please. Okay, so now we're going to get into comparing rates of change. So as we've already learned that the term rate of change is the same as the slope. So if you look here at your examples for, it's called station number 1, it says which function has the greatest rate of change. So I have a graph, I have a table, and I have an equation. So when I'm looking for the rate of change from a graph, I am looking for the slope of my line, and I'm basically counting rise over run. So if I come over here to my graph, okay, and what I'm looking for is the rise over run. So I'm going to start here at my y-intercept, which is where my line crosses my y-axis. And remember, I'm going to make a slope triangle. So if I make my slope triangle, I go from here to here, okay? So if I go from here to here and make that slope triangle, I'm counting my rise over run. So I go from here up 1, 2, 3, and then I go over 1, okay? So my rise over run then, I have rise over run. So my rise was 3 and my run was 1. So since that is a fraction, 3 divided by 1 means my rate of change here, or my slope, is going to be 3. All right? So that's for A. If I go over here to B, B is a table. Now remember, whenever we're trying to find rate of change in a table, we're looking for the change in y over the change in x. And the way that I find change in y over change in x is I just count the pattern of the numbers, okay? So if I look here, for my y values, my change in y, I go from 9 to 11 to 13, 15, 17. So I'm counting up or increasing by a positive 2. So that means my change in y is going to be 2. If I look at the x values, I go 0, 1, 2, 3, 4. So again, I'm counting up here by 1 each time. So that leaves me with 2 over 1. So then my rate of change for B is going to be 2 divided by 1, or 2. Now, if I look down below here at C, C is y equals a negative 3x plus 10. When I'm looking for my rate of change or my slope in an equation, my rate of change is always the number that is with x. So it's always what we call the coefficient of x. So whatever number is the coefficient of x or paired with x is my rate of change. So in this particular function, for function C, my rate of change is negative 3. So now let's compare and answer our question. The question is, which function has the greater rate of change? So the graph has a rate of change of 3. The table has a rate of change of 2. And the equation has a rate of change of negative 3. So the correct answer is going to be A. So on your answer sheet, all you need to do is in the cell for number 1 is type function A. That's all you need to do, is type function A. All right, so let me pause the video. I'll do the example for number 2, and then we'll be done. Okay, so if I look at station 2, I have a negative sloping line, and then I've got the table, and then I also have an equation of y equals x divided by 2 minus 7. Okay, so let's go ahead and start with our graph again. And if you notice here, this is my y-intercept. And so I'm trying to draw a slope triangle so I can count my rise over run. So here's my y-intercept. And it looks like my closest point where I have a clear intersection is right up here. So if I'm going to do my slope triangle, I would come down from that point and over to my y-intercept, okay? So I go down from that point and over to my y-intercept, okay? So when I do that, okay, I count 1, 2, 3, 4. So I went down 4, so that's going to be a -4 and over 1, okay? So in this case, I have a negative rise. So when I write my rise over run, I'm going to have a -4 over 1, which -4 divided by 1 is simply -4. All right, so that's that one. Now, if I zoom out and if I go over here to my table, all right, if I look at my table, all right, I have for my y's 2, 3, 4, 5, 6, and for my x's 0, 4, 8, 12, and 16. So, remembering that I do change in y over change in x whenever I have a table. So let's start with my change in y. 2, 3, 4, 5, 6. So that's changing by how much? 1. Okay? Then my change in x is 0, 4, 8, 12, 16. So here I counted up by 1. Over here I count up by 4. So my change in x is going to be 4, which means my rate of change for B is 1/4. Now let's look at C. C says y equals x over 2 minus 7. All right, so whenever you see something like that, that's just another way of writing y equals 1/2 x minus 7. All right, so that's how you need to read it as. So if you see any other problems in this assignment, which there are a few, where you have x over a number, just take whatever number it's over and put a 1 in your numerator and a 2 in your denominator, okay? So if you get a problem that says x over 7, just think of that as 1/7 x, okay? Or if you see another one that has, for example, x over 3, just think of that as 1/3 x, okay? So let's compare my rates of change. I have 1/2, because 1/2 is the coefficient of x. I have 1/4, and then over here I have a -4. So the question is, which function has the greatest rate of change? So 1/2, 1/4, or 4? 1/2 is the greatest of them all. So for this problem, function number C, or function C, is going to be your right answer. So on your answer sheet in the cell, you would just type function C. Okay, so this is all you have. There's 8 more of them to do. I think you'll be able to do it. So it's Friday. Finish this. Have a great weekend. And I hope this production brought to you by Mr. Gillard and the Pixel 4 has been beneficial. Talk to you all Monday. Have a great weekend.